Mrs. Poole here again with another science lesson. This lesson is on energy as we are just getting into our new unit on force and motion. So how does force and motion happen? Energy, of course. So today you guys are going to be able to describe how an object's position is affected by energy. Lesson objectives for today is to learn the difference between energy and work, be able to explain the difference between potential and kinetic energy, describe examples of energy transfer and transformation, and explain what the law of conservation of energy is. All right. So some of the things we need to clear up before we kind of get started is what is energy and what is work, because we're going to be hearing those words as we progress through this unit. So energy is not actually matter. So matter is anything that has mass and has volume, right? Anything that takes up space. So I have an eraser here and it has a mass. I can feel it and it takes up some space, right? So this is matter. Energy is not matter. Energy can be observed or measured by the work it does. And we'll get into what work is in just a second. So in other words, energy is defined as the ability to move or cause change in matter. It is also defined as the ability to do work. So what exactly is work? Like you're writing your notes right now, is that work? Your parents go to work. Is that what we mean by work in the scientific world? What exactly is work? Well, work is defined as the transfer of energy from one object to another, causing the object to move in the direction of the force. Work can be calculated, all right? And we use a special formula in science to calculate work, and that is work is equal to force times the distance moved. So use metric to measure, or metric units. We measure force in newtons, we measure distance in meters, and together, combined, work is measured in Newton meters. All right. Now, there are actually many forms of energy. These are the two main forms, which I am about to get into, but there are subcategories within these two main forms. And these two main forms are kinetic energy and potential energy. Kinetic energy is the energy that a moving object has because it's in motion. So a moving bowling ball, a ball that's rolling down the bowling lane, has energy because it is moving. And since it is moving, if it crashes into the bowling pins at the other end, it's going to cause work to happen. It's going to cause an object to move a certain amount of distance. The more mass the bowling ball has, the more kinetic energy it has. I mean, if you take a golf ball and roll it down the bowling lane, you're not going to have nearly the effect on the bowling pins as you do with the bowling ball. And not only that, but how fast you throw the ball, the acceleration at which you throw it will also have an effect on kinetic energy. So the greater the acceleration, the faster it goes, the more kinetic energy it has. So if I have, I don't know, maybe a 5-year-old going to the bowling lane and probably just pushes it down, he's not going to have as much energy, kinetic energy, as maybe the dad would have, you know, doing a big run up and toss of the ball, right? All right, so I have a little joke here. Take a look. Where do objects get their kinetic energy from? So if kinetic energy is energy in a moving object, where did that object, like this great big boulder, get its energy from? Where did this crippled man get his energy from? I guess he's not so crippled after all. Where did it come from? All right, we're continuing with Roman numeral number 2. This one is on potential energy. So the first one was kinetic energy, and now the second one is potential energy. Potential energy is the amount of energy stored in a stationary object. What does that mean? What is a stationary object? Well, it is something that is standing still. So there is potential energy in anything that is at rest. Okay, so let's say I don't know, I've got this little container here. If I drop this from a lower level, let's say I have an egg below this, okay? I don't have an egg, but let's say that I've got an egg below it. But if I drop this canister on top of an egg, it may not break the egg because it was dropped from such a small position above the egg. But what would happen if I put the egg down on the floor and then I lifted this way high and then dropped it? That sounds like the egg broke, right? Okay, so the position of the object will affect how much kinetic energy there is in that object. So here's 3 examples. Like a roller coaster, the higher the roller coaster is, the more kinetic energy it'll have. If you go to Snoopy Land at Knott's Berry Farm and you got those little hills, you're not going to have a whole lot of kinetic energy, not a whole lot of movement. But if you go up Supreme Scream and then you come down, then you're going to have way more kinetic energy, right? So this is called gravitational potential energy because gravity, the higher up you are, the more potential you have to go faster. Now, same thing with a man with a bow and arrow. This arrow is stationary, right? And if he pulls it back a little bit, it'll go flying a little bit. But if he pulls that bow way back, the arrow is going to have way more kinetic energy. So it's potential energy while it's being pulled, and it's kinetic energy as it goes flying through the air. And same thing with the mouse trap. I have 2 different mouse traps in this image down here. One is smaller, one is bigger. This bigger one has heavier wire, more coils, and so it has more potential to probably get a bigger mouse. Maybe this one's for a rat and this one's for a mouse, right? Okay, if I was trying to catch a rat, it probably wouldn't do a lot of damage in the mouse trap because its potential is not as much as the one for the rat. All right, Roman numeral number 3. Make sure you're leaving a space between these chunks of notes. Changes in energy. The law of conservation of energy. What does that mean? It means that energy cannot be created or destroyed. We don't just get energy magically out of nowhere. It comes from someplace. But we always can convert some forms of energy into other forms of energy. Okay, so for instance, potential energy is transformed into kinetic energy. So just like I said, potential energy is when it's up here waiting, it's stationary, it's not moving, but as soon as I let go of it, it is now changed into kinetic energy, and now it's moving. All right, so once it stops again, it is back to potential energy. So it can transfer back and forth, but you don't get anything new in the system that you didn't have before. Let me just explain what system is. Now, we know that in this picture here of the roller coaster, we know that there's solar energy, there's probably some wind energy, but when I talk about the system, I'm talking about the energy used just within the roller coaster, not any other outside energy sources. All right, so you can't get any more energy out of a system than you put into it. So as the pulley system drags the carts up to the top, the gravitational potential energy will pull the carts down to the bottom. This is kinetic energy, but this roller coaster on its own movement from the gravity can never ever go higher than where it started because that would require more added energy. This got its original energy from the pulley pulling the carts, the roller coaster up to the top. Same thing here. When you go up a hill, you are moving, right? Of course, you're going slow, so you're going to need to use the energy from the food you ate. But when you are moving, that is kinetic energy. Once you get to the top and you are teetering between going up and then going down, this is where you have your full potential energy. As soon as you start to teeter over the side and you start to move, that turns from being potential energy to the energy of a moving object, your bike going downhill, being pulled by gravity. All right, so we're continuing to talk about energy transfer or energy change. This one is energy transfer. When the kinetic energy of one object, such as a bowling ball, bumps into another object, such as the bowling pins, the energy is transferred from the ball to the pins. Now, there is a bit of force acting from the pins back to the ball, but we'll get into that later. The next thing is called energy transformation. And that is when one form of energy is transferred from one type to another type. So an example would be like striking a match. So whenever you have movement, that's mechanical energy. So you're striking the match. Then it changes to heat or light energy. There is a chemical on the end of the match, and that chemical burns. So mechanical energy, the striking of it, changes the chemical part of it, and now you have heat and light. Same thing with the roller coaster, changing from potential to kinetic energy. So energy transfers is when you're transferring the energy of the moving ball to some other object. Energy transformation is when you take one form of energy and convert it into a different kind of energy. All right, please don't feel like you have to write all of this down. I would like you just to be aware that there are various other kinds of energy that we're going to talk about, but each of these are either in the form of kinetic energy or potential energy. So rather than write all of this down, could you just write the bolded words? So mechanical energy is just energy of something that's moving. Chemical energy is energy that comes from within atoms. When the molecules are breaking apart or rebonding together, that is a form of energy. Electromagnetic energy is any energy that comes from the electromagnetic spectrum. So that could be X-rays, gamma rays, microwaves, light waves, all that kind of stuff. Electrical energy is energy generated by the movement of electrons through a wire. Gravitational energy is something we talked about where things from higher up are being pulled to the earth because of gravity, causing them to move. So there's gravitational potential energy and there's gravitational kinetic energy. Same thing with mechanical energy, mechanical potential. All of these have both forms of energy. Elastic energy is what we find in a rubber band or in the springs, such as in the mouse trap, or in a pinball machine. You know, when you pull back the what is that called? Pull back the handle and it pulls the spring, and then you hit the ball forward. Thermal energy is energy that is caused from the vibrations of molecules. Nuclear energy is created when there is the splitting of atoms. And we also have sound energy when there is a movement of the air molecules and that sound wave carries through to your ears and then you hear it. So we are going to be learning about a lot of these things as we move forward throughout the year, not right away. This little image right here shows how we transform energy from one thing to another, from one type of energy to another type of energy. We have chemical energy changing to light. Chemical energy, such as the food we eat, is digested and then turned into mechanical energy so you can move. Electrical energy can be transformed into heat energy. Light energy can be transformed into chemical energy through photosynthesis. And same with electrical to light and chemical to mechanical. So again, different forms of energy can be transformed into other forms. All right. In summary, you guys will be writing a summary to the end of your notes. Remember that these summaries should be 5 to 8 sentences long. I don't want you to make a bullet point summary. I want you to write a paragraph. And in your paragraph, you're going to be talking about all of these bullet points. You should be able to explain the difference between energy and work. You should be able to describe the difference between potential and kinetic energy. You should be able to give an example of energy transfer and energy transformation. And you should also be able to explain what the law of conservation of energy is. All right. Thanks for joining. Bye-bye.